All right. Okay, so let's take a look at absolute value stuff. So we're gonna take the stuff that we did in, let's just give you a little heads up about this. We're gonna take the stuff that we did in 1-6. Remember we talked about 1-6 on Thursday, and that was solving absolute value, or excuse me, solving inequalities. So we had, algebra was the same with inequalities as with equations, with the one exception being that when we multiply or divide both sides of an inequality by a negative number, what do we have to do? Flip the sign. And then we looked at some compound inequalities and some things like that that we'll touch on today also. So it's kind of a review of 1-6 and also the 1-7 stuff. All right, so solving absolute value equations and inequalities. Let's first of all remind ourselves, what absolute value is all about. How do we write the absolute value of x algebraically? I see people doing this kind of thing. So we've got the bars, right? That's our symbol for the absolute value of x. Now, remind me what we do with absolute values. If I take the absolute value of a positive number, like positive 7, what's the absolute value of positive 7? 7. So, absolute value of a positive number does nothing, right? But the absolute value of a negative number, like negative 7, the absolute value of negative 7 is what? 7. Okay, so we could summarize it, I guess, by saying the absolute value's job is to make sure that whatever is inside it ends up being positive, right? Okay, what does that look like in terms of, or how can we describe that in terms of the number line? Have you ever looked at it this way in Algebra 1? It talks about absolute value of a number as being a distance. How far it is from 0. Exactly, that's a great way to think of it. So we could think of the absolute value of x as meaning the distance that the number x is from 0 on a number line. So if we take something like, for example, the absolute value of negative 3, and we get an answer of 3, we could think of that as being because negative 3 is a distance of 3 from 0, right? Make sense? This is a really profitable way for us to look at it. It's going to help us put absolute value inequalities in a context where they make sense. We don't have to just remember stuff, but we can think of it in a way that makes sense to us. So what about something like this then? What if I've got an absolute value equation? This is a little different than what we were just talking about. Instead of taking the absolute value of a number, now we're taking the absolute value of a variable. So the absolute value of x equals 5. Now there's two ways to look at this, and it's really helpful for us to be able to see this in both ways. If we look at this from a number line perspective, what is that asking us? It wants to know, we're going to solve for x. We want to be able to know what are the numbers x that what on a number line. What's it mean if the absolute value of x, if the numbers that x could be, absolute value of x equals 5. On a number line, how do we interpret that? I want all the numbers that are what? Say it again? Yeah, a distance of 5 away from 0, right? So what are the two places on a number line? Okay, so if that's 0, what are the two places on a number line that are 5 away from 0? 5 and negative 5. Good. And so we know right away that if we were to graph this thing, I'm just going to get a point at negative 5 and a point at positive 5. Right? And so those are my two answers, aren't they? X could be either one of those two things. Now the other way to think about it is not in terms of a number line. Just think of it algebraically. Think of it in terms of what could I fill in there that's going to give me an answer of 5? I could either put a positive number into the absolute value bars or a negative number into the absolute value bars. If the answer I'm going to get back is 5, well then positive 5 or negative 5, right? So those are our two answers. Okay, pretty simple. Now what happens if we step this up a notch and we look, instead of it just being the absolute value of x, we're going to solve an absolute value equation where we've got the absolute value of some stuff involving x, an expression involving x. Okay, now, before we jump into trying to get too fancy with this, let's just forget about what's actually in the absolute value bar. So I'm gonna block it out here. We don't want to deal with it yet. I'm just gonna do this. Forget about that. So behind the black, behind the black card there, we've got some stuff. Now, if I want to know what that stuff is so that the absolute value of that number is equal to C, what are the two possibilities? Either that stuff could equal behind there could equal C, or it could equal negative C, right? If we think of it in terms of a distance on the number line, same thing. What numbers are a distance of C from 0? Well, C or negative C, right? So whatever's back there then, I'm going to set that equal to C, or I'm going to set whatever's back there, the argument of the absolute value, we'd say, if we want to be fancy about it. All that means is the stuff that's captured inside the absolute value bars. We're going to set that stuff equal to C or negative C, and that's a really key trick, because now what I've done is I've traded away all that absolute value weirdness for two regular equations that are easy to deal with. That, in general, is our goal when we're dealing with absolute value equations and inequalities. We want to make a trade. We want to trade the absolute value equation or inequality for two normal equations or inequalities that we can deal with like we always have. Does that make sense? So that's the only new wrinkle we're adding in 1.7 that's different from stuff we've had before, is just that shift, where we've got to take the original absolute value stuff and trade it for non-absolute value stuff. And then we're back to section 1.6. We're back to just solving equations or inequalities. Okay? All right, so, oh, and one key ingredient here to this process, also I want to make note of this, is that before we can start to, roll up our sleeves and do the algebra, before we can make that trade, we have to isolate the absolute value by itself on one side of the equation. So we got to get the absolute value part by itself, and then we make our trade. So what do we do with this one then? We don't care what's back there. Whatever's back there has to equal what? 15 or negative 15. Right? So whatever's back there, turns out it's a 6x minus 3. We'll just set it equal to 15, or we'll set it equal to negative 15, and we'll just solve both of those equations. In both cases, what are the two steps I go through to isolate x? Add 3, divide by 6. So if I add 3 to the left equation, I'm going to get 18. 6x equals 18, divide by 6, and I get 3. Now on the right side, if I add 3 to negative 15, I get negative 12, divided by 6 is negative 2. So those are my two answers. I get two values of x that make this work. Either x equals 3 or x equals negative 2. Those are the values that are going to make whatever's behind the black card equal to 15 or negative 15. Right?
So you don't have to change the negative 3 to positive 3?
No, good question. No, you don't. And that's a real common mistake or misinterpretation of algebra that people do. They want to say that if the absolute value makes things positive, then everything inside the absolute value should individually become positive. That's not what we're doing. What we're doing is we're saying whatever that expression inside the absolute value bars is, we won't worry about it, that either has to have a value of 15, because then the absolute value of that expression would equal 15, or it has to equal negative 15, because then its absolute value would also equal 15. So you don't do anything tricky with the absolute, you don't do any algebra with the absolute value equation. We don't want to. The algebra using absolute values is tricky. There are a bunch of different rules that we don't know about yet. There will come a point at some point where we'll learn to do some algebra with an absolute value equation, but we're not doing it now. Now we're going to do all our algebra without the absolute value bars there. We're going to make the trade first to get rid of the absolute value bars and then do the algebra. Okay? Does that make sense? We could check this. If I plug 3 in for x, I get, 6 times 3 is 18 minus 3 is 15, and the absolute value of 15 is 15. If I plug in negative 2, I'm going to get 6 times negative 2 is negative 12, minus 3 is negative 15. And the absolute value of negative 15 is 15, right? So either way. Okay, what about this one? What do I have to do there? Yes? Yeah, I got to get the absolute value by itself first, don't I? So the very first thing I've got to do is to get that by itself, I've got to add 3 to both sides. Right? Now, once I add 3 to both sides, now I've got an absolute value equation that I can make a trade for, right? Now we're done. We got to make our trade. So whatever's inside the absolute value bars is either going to be what? Equal 11 or negative 11. So we'll split the absolute value equation into 2 regular equations and solve, and we're done. It's no big deal. So I'm just going to subtract 7 from both sides and divide by 2, and I get these 2 results. Those are my solutions. Okay? Questions on that? Any part of that that's seeming strange? Okay, let's take a look at how we deal with inequalities then. Solving absolute value inequalities. Now, I want to, before we jump into this, I want us to think about what we might expect from a situation like this one. Now, what if, let's just block out what's in here again. Might seem kind of cheesy, but if I've got some number and I want the absolute value of that number to be less than c, what does that mean in terms of our number line? Now let's compare it to the situation where I had, compare it to this, where I had the absolute value of something, that's a question mark, is equal to c. You guys told me that for that situation there, I could think of that as a number line. There's 0. And I'm going to pick whatever's behind, inside the absolute value bars, has to have a value of negative c or positive c to be a distance of c from 0, right? And then we don't know what's back there. It might involve some x's and things, and then we just got to solve for x, right? What about this case? What if instead of whatever's in the absolute value bars, whatever behind the black card, instead is less than c? What is that telling us about the distance from 0 then? What's that mean? If the absolute value is equal to c, that meant that the distance from 0 was equal to c. Right? This distance right here was exactly c. Right? What does it mean if the distance from 0 is now less than c? What's that going to look like on our graph? You fill in the blanks. If here's my number line, there's 0, there's negative c, and there's positive c. If I had to graph this then, the numbers that are inside the absolute value bars, where would they go? If they're less than c away from 0, are they there? Would that work? No, that's too far away. That's a distance that's greater than c away from 0. Would it work right there? No, that's not going to work either, is it? Would it work right there? That would work, wouldn't it? Let's make that green. That one worked. Would that work right there? Is that point less than c away from 0? Distance of c? Yeah, that distance is c, so I'm closer than c. Right? Closer than c. Would that work right there? Would it work right there? Right there? Right there? Even right there, right? So there's an infinite number of possibilities. If I graph them all, what's the graph going to look like? Don't I have to just fill all this stuff in? Do I include C? I don't include C because C is not closer than C to 0, is it? So I got to put an open circle there. Now that looks an awful lot like what we dealt with on Thursday with compound inequalities, doesn't it? Which of the two kinds of compound inequalities had a graph like that? Was it the or the and? Which one was it? Do you remember? Now think, what did the or look like? Yes, sir. The circles actually, in this case, if I had just put an equal sign there, I would have filled in the endpoints, right? So that's why those were open circles. But what I'm really asking about, I guess, to be more specific, is why am I filling in the interval between the endpoints instead of outside of the endpoints? Which one of the two kinds of compound inequalities corresponded to that? Now, wasn't the or the one that stuck out like the oars on a boat? Right? So this must have been the and, right? The and is the one that's between, and the oars are the one that are outside, like the oars on a boat. Agreed? Okay, so then if I get rid of all this nonsense, what we're saying is this becomes an and problem. And here's our recipe. Whatever was inside the inequality to start with is what's going to end up going between negative C and C, right? That goes into the and, that's the middle of the and inequality, right? It's pinched between, whatever that number is, it's pinched between negative C and positive C, right? So that's our strategy. We can make a trade. When we see this weird absolute value inequality, and it's a less than inequality, we automatically know that that's going to get traded for, that's going to get traded for that. A normal compound inequality, an and inequality that I can solve. Okay, and now we can just shift gears out of section 1.7 and move back to 1.6 and do the algebra. Okay? Now what about this one? Let's shift down to this guy here. If I'm taking the absolute value of something, right, it's going to give me a number. I don't care what's back there yet. And I want that absolute value to be greater than C. Doesn't that mean that its distance from 0 is more than C? Right? What kind of what's the graph going to look like there? If I draw my number line, there's 0, there's backwards C to negative C, there's forward C to positive C. Which kinds of values are going to work now? That's not going to work there anymore, is it? Because that distance from 0 is less than C. I want values that are bigger than C, right? That are further away. Their distance from 0 is more than C. So that's not going to work, and that's not going to work. I have to go outside those limits, don't I? These are the kinds of values that are going to work, because that distance from there back to 0 is more than C, right? Make sense? So the absolute value of, that would work. The absolute value, or the distance from 0, is greater than C. I could also go out in the positive direction out there, couldn't I? Right? So now we're looking at an or inequality. Something like this. Right? And so there's our trick. Our trick is when we see an absolute value inequality that's a greater than inequality, we're going to make a trade for two or inequalities, right? A compound or inequality. Two extreme cases. Either whatever's inside the absolute value bars is going to be bigger than C, greater than C, or it's going to be further to the left than C, than negative C. It's going to be less than negative C. It's got to be out, right? Does that make sense? It could be very negative or very positive. Okay? That's it. And then we just do the algebra. So let's look at a couple examples. Okay, what about that one? I've got an absolute value inequality, but the important part here is this part. It's a less than or equal to, right? So I'm talking about a distance from 0 that's less than or equal to 21. So I'm closer to 0 than negative 21 or positive 21. So I'm going to be inside, right? It's an and inequality, isn't it? I want close endpoints. So I'm going to trade this for an and inequality. And what used to be in the middle of the, or what used to be inside the absolute value bars, now goes in the middle of the and inequality, right? Pinched between positive 21 on the top side and negative 21 on the bottom side, right? So now this number is where it's supposed to be. Its distance from 0 is less than 21. But I'm not really interested in just that number. I want the values of x that'll make those numbers. So I got to solve for x. Now, what are the steps I go through here to solve for x? In order? First, I add 9 to everything. Good. So if I add 9, negative 21 plus 9 is negative 12. 21 plus 9 is 30. And then to get that x by itself, last step, divide by 4. Negative 12 divided by 4 is negative 3. 30 divided by 4 is 34ths, or 15 halves. So 7.5 is a decimal, right? And I got the x by itself. There's my solution. Those are the values of x that make this happen, that make this expression be pinched between negative 21 and positive 21. But we actually include the negative 21 and the positive 21, don't we? Because I've got the equal sign is included in our inequality. So are the endpoints going to be solid or open? Solid, because I'm included, because I've got that equal sign there, right? So if I graph this thing, I know at negative 3, I'm going to have an endpoint of that interval. And at positive 7.5, I'm going to get an endpoint. And which way do I shade? Horizontal boat or in the middle? In the middle. Yeah, it's an and, isn't it? So that's it. Right? That's our solution. There's the solution written algebraically. There's the graph of the solution. Okay, one more. What about this guy? What do I have to do first before I even start? Good. Subtract 3 from both sides. Get the absolute value by itself. Okay, now that I've got the absolute value by itself on one side of the inequality, I gotta focus on the inequality sign. It's a greater than inequality. So the distance from 0 is more than 8, greater than or equal to 8. So that's going to be big distances. Or is on a boat, right? So I'll trade this for an or inequality. And I got two possibilities. Either 3x minus 2 is going to give me a number that's greater than or equal to positive 8, right? Or it's going to give me a number that's less than or equal, meaning less than meaning to the left of. Less than and left of, right? Less than or equal to negative 8. I just solve them both. Add 2, divide by 3, and I got my answers. So I'm going to get endpoints at 3 1/3, 10/3, and at negative 2. And which way do I shade this time? Outside. Yeah, horizontal boat. Make sense? Okay? All right, and that's it. That's it for chapter 1. I think we actually maybe have time. I'll make one up. Get out your notebooks and try this one. Okay, try this. Try that. Solve for x. first? Say it again. Add 11. Okay, good, because we got to get everything inside the absolute value bars by itself. Right? The absolute value bars has to be by itself on one side of the equation. So I add 11 to both sides and get absolute value of 2x plus 3 is less than 3. Okay? All right, now what? I can't,
You have to set up 2 problems.
oh, I gotta set up 2 problems. Right, now I'm to the point where I gotta get rid of the absolute value bars. I gotta make a trade. Once I get the absolute value part by itself, I'm gonna make a trade for non-absolute value stuff. A 2-for-1 trade. I'll trade this 1 inequality for 2 regular inequalities, so a compound inequality. Now, which kind?
-3 +3.
Okay, if it's a less than sign there, the absolute value is less than a number, does that mean and or? That means and, doesn't it? Good, right? Because we want distances that are closer to 0 than 3, so we're going to put inside it's an and. All right, so then everything that starts out inside the absolute value bars goes where? In the inequality. Okay, inside, in the middle. Good, so that's going to go inside, and it's and, right? And so what are the numbers that form the boundaries then? So this 2x plus 3 that's inside the absolute value bars is greater than what? -3. And less than 3. Exactly. And now, what are the 2 steps we do? Add 3, subtract 3, so you're right, and divide by 2. So if we subtract 3, we're going to get -6, 2x, and 0, right? And if I divide everything by 2, then I get x in the middle. 0 divided by 2 is 0. -6 divided by 2 is -3. Good. Now when you look at the assignment, the Moodle problems are a little strange. They look like this. Okay, let's take a look at one of these real quick, if we have time. Yeah, let's look at one that I've actually got filled in because we're about out of time. Look what this says here. It says, complete the solution to the given inequality. Choose the correct inequality symbol from the drop-down menu. Okay? And then it says, enter the number portion, numerical portion, as an integer or a rounded decimal, the 2 places. So if I solve this guy, wouldn't you agree? I'm going to subtract 1 and divide by 7. So I get x is less than 4/7. So I just pull down the less than symbol from the menu. I convert 4/7 into a decimal and round it 2 places, so it's 0.57, right? And then it says describe how the solution would be graphed. But wouldn't I have an open endpoint at 4/7, right? And I made that wrong on purpose. It's supposed to be 0.57, isn't it? And then the portion of the x-axis to the left, because if x is less than 4/7, we're going to graph the part to the left. To the left of the dot should be shaded. Now when I checked this, I got partial credit. If you want to know where you missed something, just mouse over the solutions and it'll tell you how you did. See, that's the one that I missed. I got 0 out of 2 on that one because it was supposed to be 0.57. Now if I try that, I should be good. Ah, there we go. Okay, have a good lunch.